So the last part of the hypothesis testing chapter now. So there's a saying that says a stop clock is right twice a day. So someone says to you, I think the clock is broken in the other room. And you walk in and you glance at the clock and you know it's 1 o'clock. And the clock says 1 o'clock. And you go back and you say, no, it's not. It works fine. It's got the right time on it. Of course, the thing is, the clock actually might not be working. It just might be happen to be correct. And this is kind of the idea of what's going on when we talk about a significance level. A significance level is basically because we can't always be sure, because we know that random things can happen. And the significance level is about that. So this is the definition of the significance level. The significance level of a test is the probability of rejecting the null hypothesis when it is in fact true. I.e., that you say that something is wrong, i.e. that the person said that the clock was broken and you said, no, it's not. You said, no, you're wrong. The clock is working fine. But actually the clock is broken because things can happen by chance. I.e., an example you could say is that you could accuse them of cheating and actually they weren't cheating. I.e., you might say that I was cheating with the card game that we played at the very start of this. Whereas I might not actually have been cheating. I might have had a fair pack of cards, but it just happened to come out 4 to 11. Of course, I might have been cheating. But the idea is that if you use a 5% significance level, the probability of rejecting, a probability of accusing me of cheating when I actually wouldn't, is 5%. Now you can think carefully about whether you should make 5% bigger or smaller. If you make it smaller, then you're more sure that they are actually cheating when you accuse them. You could feel very confident in your accusation of cheating or that something is strange. But that has a flip side as well. And that is that if you increase the size of your significance level, you're going to accuse more people of cheating that actually weren't. i.e. you're going to be less sure that when you accuse people of cheating, that they were actually cheating. But anyway, there's the definition on the screen. You might be asked to quote that. Significance level is the probability of rejecting the null hypothesis when it is in fact true. So the final thing that we've got to do here is we've got to do an example of a two-tailed test. And I've picked one here with a kind of a couple of parts because they can be kind of split up into different parts. So I'm going to give you a second to look at the question on the board. So what's the key pieces of information here? So we've got 30%. That's probably going to be my P. And I've got N is 20 over here. I'm using a 10% significance level. And is there an observed? Well, not yet. You'll actually see that that comes in later in the question. Because what we've been asked to do is to find the critical region first, before we even know what the observed value is. And also, we've been told that each tail must be less than 0.05, so it's not as close to, it's less than 0.05. So, what have I got? I've got that X is the number of baked beans of customers buying single tins. And I can see that X is binomially distributed, and I've got 20p. Give myself a bit more space here. Okay, so we have got find the critical region. All we've got to do is the critical region here. We're not actually being asked to write down our hypotheses. We know that it's going to be a not equal to, so I'm going to write them down kind of on the right hand side. I'm going to say I know that my H0 is going to be P is equal to 0.3 from the 30%, and I know that H1 is going to be P is not equal to 0.3, and I need to find my critical region. So I'm going to find the lower one first. So I'm going to go to my calculator. I have got n is 20, so I think it's pretty safe for me to put in all 20. Doesn't take too long. Binomial CD list. I'm going to put in 20. That wasn't bad. And n is 20 and p is 0.3. Now let's look at the lower tail. Where does the switch happen from less than to greater than 5%? Happens between 2 and 3. So let's do my working. The probability of x being less than or equal to 2 is equal to 0.035, which is less than 5%. And the probability of x being less than or equal to 3 is equal to 0.107, which is greater than 5%. So I can see that it's going to be less than or equal to 2. Now let's look for my 5%, 95% switch. And that happens between 8 and 9. So remember my trick, if it's 8 and 9, then it's going to be 10 and greater. So we know the answer is going to be 10 and greater. If it's 8 and 9, is the switch between less than and greater than 95%, it's going to be 10. So let's see my upper. And remember, I leave a gap because I'm going to do 1 minus the probability of x is less than or equal to 8. And my other one is going to be 1 minus the probability of x is less than or equal to 9, which is going to be the probability of x being greater than or equal to, do your number line, have a quick check, 9. The probability of x is greater than or equal to, do your number line, have a quick check, 10. So this is 1 minus 0.887, and this is 1 minus 0.952. So I need to work out these probabilities. So I go onto my calculator. Remember the store trick. I'm going to store as A, and I'm going to store the other one as B. 1 minus A. This is 0.113, 0.113, which is greater than 5%. And 1 minus my value of B is 0.048, 0.048, which is less than 5% as required. Reminder that we're doing at the 10% significance level, but we've split it into 2 bits of 5% at each end. So I need to just move it down for the final answer. So my final answer is that the critical region is x is less than or equal to 2, or x is greater than or equal to 10. So just to be clear, that's because this was the one that was okay, and this one was the one that was okay. Okay, now let's carry on with this question. Write down the actual significance level of the test based on the critical region from part A. Well, that we're going to need the 2 probabilities that I just had on the screen. I'm going to need my, I'm going to highlight them. I'm going to need to add up this probability with this one. So I might as well do this exactly. Since I actually have this one still on the screen, I could get it back. I'm going to store that value as C. Good. So I can see my C value is this. And I can go back into menu and I'm going to get that value back. I could do this approximately. And I could get a single variable and I want less than or equal to 2 for my n is 20 and 0.3. And that's my 3.5. I'm going to store that as D because I want to add those two things together. Go back to 1, C plus D, and I get that as my actual significance. So my working is that I want to do 0.035 plus 0.048, giving me a total of 0.0834. There was some actually decimal places there as well that I've missed out, but I've used the calculator and I've got my exact answer. Okay, so critical region is less than or equal to 2, greater than or equal to 10, and they have found that the observed is 11. Is that in the critical region? Yes, it is. So I need to think carefully since we are going to have to do this test. We didn't actually have to set up the hypothesis at all in here. All it's asking me is to comment on this finding in light of your observation. 11 is in the critical region. And that is because 11 is greater than or equal to 10. Didn't matter that it's not less than or equal to 2, it's just in the top part. And I'm going to conclude with a very clear conclusion. There is sufficient evidence to suggest that, and I pause and look back at the question. What are we doing? It's the number of customers have bought single tins. That the number of customers buying, take your time, it takes a little bit, but it's worth it, single tins of baked beans. And now this is a thing, the last part of this is what sometimes people get wrong. The answer is, the last part is has changed. Now, you might think that we've actually got evidence that it's increased because it's in the top critical region, but we don't. The hypothesis was whether it has changed, and all we can do is answer what the hypotheses we're testing. So the answer is has changed. And that last bit, I'm going to underline and say that is important. Okay, I'm going to finish off by giving some suggested questions. I suggest you try a few questions of two-tailed tests from exercise 7D. You can do and more until happy, and then try a couple of mixed exercise questions and eventually do more. The more you do these, the more you'll see that they're very similar each time, and eventually you will get the hang of it. Okay, that's the end of this chapter. I hope that has helped.